In this problem, a solid glass sphere of refractive index n is equal to root 3 and radius r contains a spherical air cavity of radius r by 2. Here it is shown air cavity. Total thing is made with a sphere is made with of a solid glass as shown in the figure. A very thin glass layer is present at the point O so that the air cavity refractive index n is equal to 1 remains inside the glass sphere. An unpolarized unidirectional and monochromatic light source S, here is the S, emits light ray from point inside the glass sphere towards the periphery of the glass sphere. So the light reflecting back into the sphere on falling on the periphery of the glass sphere. If the light is reflected from O and fully polarized, then the angle of incidence at the inner surface of the glass sphere theta, the value of sin theta is. So here, whenever light reflects back from the periphery of the glass sphere, this angle of incidence theta we want to, that sine of this theta we have to calculate. See here, the path of the light ray is drawn, and you may wonder how this diagram I got. Nothing. I started from O. The light ray is falling here and the light ray is going here. This light ray is polarized light. This light ray is polarized and this light unpolarized. So when light ray polarized due to reflection here, I can apply the Brewster's law. From Brewster's law, how can I apply this Brewster's law here? Outside glass is there, inside air is there. Air refractive index is equal to 1. Outside the glass refractive index is given as root 3. See here how I just imagine the path of light ray here. When light ray traveling from denser medium glass to rarer medium air, the angle of refraction is greater than angle of incidence. This is the angle of incidence. This is angle of refraction. So here the light ray must go like this. Like this, I started my construction of the path of the light ray from O. Here, due to refraction, the Brewster light being polarized, this reflection, what is the law of reflection? Angle of incidence is equal to angle of reflection. So these two angles are equal. These angles are equal to the theta p, means polarizing angles. Right. So let us calculate this angle of polarization. What is the formula? When light is coming from denser, when light is coming from denser to rarer. In rarer, this light ray is get polarized. See here, N2 is equal to tan theta p. Yeah, sorry. N1 is equal to tan theta p. What is N1? Root 3 is equal to tan theta p. So angle of polarization is equal to 60 degrees. Why? Because tan 60 is equal to root 3. So here this RP is equal to 60 degrees. Right. Here see, this is the center of the glass sphere. This is the center of the air cavity. From center of the air cavity, whatever the line I drawn to the point of incidence of light, this is the normal. All the angles of incidence and reflection, refraction, whatever it may be, In light, we used to measure from the normal. So from the normal, it is 60 degrees. So this is the radius r by 2. C dash is also r by 2. And here C dash to this here. This is also normal. Why? Because I want to measure the I and R. So wherever the light ray is falling at the point of incidence, I draw a normal. Normal means joining this point with the center of the air gravity. This is also radius r by 2. So this is this for this line, this radius is making 60 degrees. That means this is also 60 degrees and this is also 60 degrees. This I have to calculate angle of incidence. For that, I will use Snell's law. Snell's law. So equation of refraction I will write. See, outside N1 is there. N1 sin I is equal to N2 sin R. N1 is equal to root 3 sin I is equal to N2. N2 is 1. Why? Because air refractive index is 1 into sin R. R is angle of refraction. It is also equal to the angle of polarization, that is 60 degrees. So sin I is equal to root sin I is equal to root 3 sin I is equal to sin 60 degrees is equal to root 3 by 2. So here root 3 cancels. So sin I is equal to 1 by 2. That implies I is equal to 30 degrees. So here I is equal to 30 degrees. Right? This is what we have to calculate. Brewster's law, Snell's law, that's all. Two laws here. Okay. See, at the periphery of the glass sphere, the light ray is reflected. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. This theta we have to calculate. Sin of this theta we have to calculate. What I do? I will join these two by a line. This is not there. I only drawn. Why I have drawn? I got a triangle here. I will give some names so that we can recognize it. C, A, B. Here it is 60 degrees, it is 30 degrees. So this is also 30 degrees. This is 30 degrees, this is 30 degrees. That's why this angle is, I'll write in color so that this angle is 120 degrees. Right? So this is theta, so this is also, this is 30, so this is 120. So this triangle we don't know, we don't want. This triangle only we want. See here 30 degrees, so this is also 30 degrees. So this triangle I am drawing here like this. This is the triangle. This is C and this is A. This is B. This angle is equal to 120 degrees. This angle is equal to theta. This line, see, wherever light is falling at the angle of incident, this point to the center of the glass sphere, I draw a line. This is a normal, and this is not only a normal. CB is a radius of the glass sphere. So this is radius, right? And theta, sine of theta, this is not a right angle triangle to apply. That's why we can use sine rule here To apply sine rule, CA length I need. See here, you see this is 30. So component of r by 2, this is r by 2, this is component of r by 2 here. This component is equal to what happened? 2 r by 2 cos how much? 30 degrees. And here also, this is also 30 degrees, this is also r by 2. R by 2 cos 30 degrees. So 2 r by 2s are there. 2 cancel. Now for this triangle, I apply sine rule. Right? I apply sine rule for this triangle. This one I have drawn here. So the component r by 2 component towards CA is equal to r by 2 cos theta, cos 30 degrees. Here also r by 2 is there. This component along AC is equal to that also r by 2 cos 30. So r by 2 cos 30, r by 2 cos 30, 2r cos 30 by 2. So 2 cancels. So finally I got the triangle like this. So this is C, this is A, this is B, this theta we have to calculate, this CB distance is radius R, CA distance is calculated, that is R cos 30 degrees. So I use sine rule. By using sine rule, so what is the sine rule? Right, let us apply that one. This problem is very simple problem. See, CA or AC, whatever it may be, AC by opposite angle sine value is equal to CB, CA, CB or BC by this angle is equal to 120 degrees. So sine of 120 degrees. So I used a sine rule. So AC value, what is AC value? R cos 30 degrees by sine theta is equal to, what is CB? R by sine 120 degrees. Right? Here R cancels. I want sine theta. So sine theta is equal to cos 30 degrees sine 120 degrees. What is cos 30? Root 3 by 2. What is the value of sine 120? Root 3 by 2. So sine theta is equal to 3 by 4. Sine theta. Sine theta. Theta is the angle of reflection or angle of incidence at the periphery of the glass slab. So this is 0.75 also we can write. So for the question number 11, the answer is 0.75 or simply 3 by 4.